In this video, I want to talk about solving systems of nonlinear equations. So here we're given a system of nonlinear equations. Specifically, this is a circle with actually a linear equation. So really, for something to be a system of nonlinear equations, at least one of the equations has to be nonlinear. So we have a circle, which is definitely a nonlinear equation, and we have just a normal linear equation as well. Okay, we want to see if we can solve this. Okay, so the first step here is going to be, we want to try and find a way to do some substitution. So let's go ahead and solve this bottom equation for y. So we can take 2x away from both sides. And that's going to give us that y is equal to negative 2x minus 5. Okay, and what we can do then is we can take this value for y and we can plug it in right here. So that's going to give us x squared plus negative 2x minus 5 squared is equal to 10. And now we need to expand negative 2x minus 5. So if we do negative 2x minus 5 squared, that's the same thing as negative 2x minus 5 times negative 2x minus 5. And if we do our FOILing here, we'll do our firsts. Negative 2x times negative 2x gives us positive 4x squared. Okay, then our outers, negative 2x times negative 5 gives us plus 10x. Negative 5 times negative 2x is plus 10x again. And then negative 5 and negative 5 is plus 25. So if we simplify that, we get 4x squared plus 20x plus 25. And now we can rewrite this equation here with this new expanded version of negative 2x minus 5 squared. So we'll have x squared plus 4x squared plus 20x plus 25 equals 10. And we can take 10 away from both sides and do some combining of like terms. And that's going to give us 5x squared plus 20x plus 15 is equal to 0. And now what we can do is we can solve for x. So to do this, we can recognize that all three of these terms are factorable by 5. So if we pull a 5 out, we'll get 5 times x squared plus 4x plus 3 is equal to 0. And that 5 really isn't going to play any major role here. So we can just go ahead and factor this right-hand side here, or factor the quadratic here. So we'll have 5 times two factors of x squared plus 4x plus 3. So we need to find two numbers that multiply together to give us 3 and add together to give us 4. Okay, so I'm thinking 3 and 1. So we'll have x plus 3 and x plus 1 is equal to 0. So this whole thing is equal to 0 when x is equal to negative 3 and when x is equal to negative 1. So those are our two x solutions here. And what we can do now is we can take these values and we can plug them right back in up here to y equals negative 2x minus 5. Okay? So if we start with x equals negative 3, we'll have y equals negative 2 times negative 3 minus 5. Well, negative 2 times negative 3 gives us positive 6. So we have 6 minus 5, which is 1. So one of our points is going to be the point negative 3, 1. Okay, and then how about we have x equals negative 1. Okay, well here we'll have y equals negative 2 times negative 1 minus 5. Negative 2 and negative 1 give us positive 2. So we have 2 minus 5, which gives us negative 3. Okay, so we'll have the point negative 1, negative 3. Okay, so these are our two solutions here. So we'll have negative 3, 1, and we'll have negative 1, negative 3. Okay, let's look at a slightly different example here. Here we have x squared plus y squared equals 13. And then we have x squared minus y equals 7. Okay, and again, I think we want to try substitution here. So let's go ahead and solve both of these equations for x squared. Okay, so if we solve this first one here, we'll get x squared equals negative y squared minus 13. Or you can write this as 13 minus y squared. Either way is fine. And this second one here, we'll have x squared is equal to y plus 7. Okay. So what we're going to do is then we're going to replace x squared here in the, well, either one really. So let's go ahead and replace the x squared in the second equation with the equation we have on our first equation here. Okay, so that's going to give us, we'll have, if we take this x squared here, substitute in here, that's going to give us y plus 7 is equal to 13 minus y squared. Okay, y plus 7 is equal to 13 minus y squared. So now let's see if we can just solve for y. Okay, so if we rearrange this, we can go ahead and subtract y from both sides. Well, I guess let's go ahead and add y squared to the other side. So if we add y squared, that way we don't have to deal with negatives. These will cancel. So we'll have y squared plus y plus 7 is equal to 13. Okay, but if we take 13 away from both sides, we'll get y squared plus y, looks like minus 6 is equal to 0. Okay, so we need to find two numbers that multiply together to give us negative 6 and add together to give us 1. So if we do that, this is the same thing as y plus 3 and y minus 2 is equal to 0. So multiply y plus 3 and y minus 2 together, then that's going to give you your previous quadratic, set this equal to 0. And that means that our two y solutions are going to be negative 3 and positive 2. Okay, and now what we can do is we can take these y solutions and we can take them and plug them right back in, probably to this one here. X squared equals y plus 7. So if we have y equals negative 3, okay, we're going to have x squared is equal to negative 3 plus 7. Okay. So if we have x squared is equal to negative 3 plus 7, that's going to give us x squared is equal to 4. So then if we take the square root of both sides, we're going to have x is equal to plus or minus the square root of 4. Because remember, we have to do the positive and negative here. Or specifically, plus or minus 2. Okay? So we actually get 2 points just out of y equals negative 3. So we're going to have positive 2 and negative 2. So our 2 points that come out of here are going to be x equals 2, and then y equals negative 3. And then we'll have x equals negative 2, y equals negative 3. Okay. And then we have our other y value, which is y equals 2. So y equals 2, we'll have x squared equals 2 plus 7, which is equal to 9. Okay, so we'll have x squared is equal to 9. We can take the square root of both sides, and we get x is equal to plus or minus the square root of 9, which is equal to plus or minus 3. So once again, we're going to get 2 points as well. So we'll have the point, we have 3, we have positive 3, 2, and then we'll have negative 3, 2. Okay, so we actually get 4 points out of this. So we get these points, 2, -3, and -2, -3, and 3, 2, and -3, 2. So really, these types of systems of nonlinear equations, there's lots of different examples here. I would just encourage you to go on Alex and then try to do as many of them as you can. They're really not that bad once you get the hang of it. You really just have to play around with different substitutions. There are ways to do it using elimination as well, but typically I think using substitution is probably the best method here.